this assignment is not just how to troubleshoot a circuit, it's how to troubleshoot the appliance. Because, you know, a lot of people think troubleshooting is the machine doesn't do something, like the dryer runs and it don't get hot, and you go to the diagram and you just start making tests. But you know, it's almost like when you go to a doctor. The doctor asks you a bunch of questions. You know, where does it hurt? Does it hurt when you're breathing? Does it hurt when you're walking? You know, asks you specific questions trying to narrow down what the problem is and the symptoms behind those problems. So the same thing as technicians, you know, our troubleshooting begins when we get the service ticket and we got the brand, the model, and the description of what the customer's saying the machine's not doing. Immediately, you know, you should be looking at it and saying, oh, this dryer is not heating. It's running, but it's not heating. Already in your head, you're saying, well, it could be heating element, it could be yada, yada, yada. So you're already, that's the beginning of troubleshooting, is to the thought process of what could be the problems. And sometimes, you know, if you diagnose ahead of time, you say, oh, I want to bring these parts with me. I know they have them at the office because it might need one of these things and I don't have it on my truck, so I can get the first time complete. But when we troubleshoot a machine, this is not exactly this dryer, but it is a dryer, so I only put it up there because it's a very simplified diagram. Some of the ones are a little more complicated. But when we go to a dryer that's not working, we have to make tests. So I have these meter leads here, and this meter is just there for show, but I can put the meter leads on test points, and then I'm going to put them on the machine in the same point on the machine that they would be on the diagram. So if you could look at the diagram and map out how the current's flowing through that circuit, then you would know how to test it out. Okay, so let's take a look at the first problem here on the dryer. It says dryer motor doesn't run. Okay, they might say it doesn't start, it doesn't do this, it doesn't do that, but they say dryer motor doesn't run. They press start, nothing happens. Okay, so first question says list the controls which prevent the motor from running. Then the second one says identify in order the parts that would most likely fail. I mean, some of you guys work on cars. And if a car is not running right, you always say, well, we're going to check the EGR valve, or we're going to check this because with this many miles, this is one of the things that cause it to run rough or not run properly. You know, certain things in a vehicle, you would know, hey, I'm going to change this before I change that. You know, you're not going to change the key on the car unless, you know, it's a key with a code in it, and it's one of the last things that you would check. So if we're saying the dryer motor doesn't run, the next thing to do is to look at the machine. Now, before we take anything apart, we want to look at the wiring diagram. Dryer motor don't run, we're talking about what load? What load in the machine are we talking about?
Motor.
The motor, okay? So the next thing to do is to figure out the circuit or the path that electricity flows through that motor. So if we took and looked at this here, power comes in, goes through here, it goes this way, and out. All right? That is the circuit for the motor. How much voltage does the motor get? 120, 240, how much does it get?
120.
120. Now this dryer does get 240. It's got one of these 240 volt plugs on them. But 240 is really for what?
The heating element.
The heating element. So we really don't need the 240 to get it to work. We only need 120 volts. But it's important to know that only two of those wires give us 120 for the motor, but we can get 120 from the other wires. For example, if I check line 1 to neutral, I can get 120 volts. Mm-hmm. If I check line 2 to neutral, I'm going to get 120 volts, but the motor is getting power from which of those two lines? Line 1. So line 1, I know it says yellow here in the diagram, but line 1 is the black wire. It's hard for you to see, but I can see black. The white in the ground is here, and the red is here, line 2. So line 1, neutral, and line 2. So the first thing you want to do once you've identified your circuit is say, okay, I need line 1 and neutral to be good in order for that motor to work. So we're going to take our meters, leads here, and we're going to put one on line 1. We'll put one on line neutral, but on neutral. That would be taking our meter, put our meter on voltage, okay? Now the safest way to do it is to unplug the machine from the wall and then connect the meter and then plug it back to make the test. Make sure you guys have your safety gloves on when you're doing those tests as well. So we're gonna check neutral here and line 1 like this. And I have it just like the picture where I have the back meter lead is on line 1. It's okay. The black meter lead is on line 1 and the red meter lead is on neutral. Okay, does it matter in AC voltage if I had them reversed, if I had the red meter lead here and the black meter lead there?
No.
No, it does matter on DC voltage. But on this machine it doesn't matter the polarity of the meter because either way it's going to read that voltage. So that's the test. Okay, now before I test anything else, if I have proper voltage, I can go further and make more tests on the machine. I want to make sure that it's working. So the next thing I want to do before I start testing components is I've already highlighted the circuit that works. I want to look at everything in that circuit that has to make the motor run. Okay, if the motor's not running, does this switch have anything to do with the motor starting?
No.
No, so I wouldn't check it. Does this switch have anything to do?
No.
No, it's not in that highlighted circuit. So then what we want to do is we want to identify all the components, which is this timer switch, this drive motor, thermal fuse, push to start relay, and door switch.
Would
Now-
the drive motor be a control also?
Well, drive motor's a load.
Right.
If the drive motor's bad, will the motor run?
No.
No. So yeah, it's not listed as a control, but it is something in that circuit we have to check.
Okay.
I know I put here list the controls, but the load is also something we need to look at. But I was asking for controls because when we start testing, it'll make sense what I'm trying to say.
I was
Okay?
putting it down, but when you resaid the whole thing about controls, I kind of scratched it out.
Yeah, that's fine. So then here, what I wanted was for you to list the controls that prevent the motor running. So it would say timer switch. And in this case, it's Y to RE. The next thing, and we'll skip the motor for now, thermal fuse. Then I got PTS, which is push to start relay. And door switch. How many switches or controls are in series with that motor? 4. Now we could have added the centrifugal switch in the motor, but the motor would at least hum. If I hear the motor humming and not running, I wouldn't worry about any of the things I just listed because if any of them are bad, the motor's not even going to hum. All right? So if it hums, problem's either one of my 2 windings in the motor are at fault or the centrifugal switch is bad. But either way, in order to fix the problem, what's the answer? Replace what? Replace the motor. Okay? But we're going to assume that we press start and the motor doesn't even hum. It doesn't do anything. Okay? Now the proper test would be to go to where? If I have voltage at the machine, what should the next step be?
The door switch?
Check the door switch. Anybody got any other ideas?
Maybe you check any of the switches.
We missed one step already.
The therm.
No,
The buzzer?
no.
No, the buzzer isn't in the circuit. The only other thing I can think of is the timer switch.
No. We missed a step.
Check how
What's
far
that?
the voltage goes.
No.
Backtrack as you're going.
Before I even do this voltage test here, I need to prove what the problem is.
Oh, so try to actually run it and see if
Verify what the complaint is. Before you start taking covers off and panels off, go to the customer and say, okay, ma'am or sir, what's the machine doing? He says, oh, I press start, nothing happens. You know, I don't know how many times I've known me and other techs go out to a washing machine not working. Yeah, my washing machine's not working. And the lady didn't know the husband unplugged it in the garage because he needed the outlet for his drill or something. And then plugged the washer back, and she's got clothes in there, and she's trying to start the washer, don't work, it wasn't plugged in. Housekeeper didn't plug it back in or whatever. You know, and if you don't think about that, the first thing you do is start taking panels off. I'm gonna see if the motor's got power. Okay? But if we got proper power. Now, on a 240 volt outlet, if you wanted, we could also check the voltage where this goes into the outlet. But one, you have to have long enough meter leads to get in there. Or if not, if you take this plug and you back the plug off just a little bit, it's still making connection inside. You can touch these metal prongs with your meter while it's still plugged in and see if you got 120, 120, 240. Okay? So, again, verify the problem before you start taking panels off. Remember, you want to make your job as simple as possible. Now, the next step will be to see if the motor itself is getting power. Okay? That's going to take a minute. It's not a big job to take this thing apart. And some other machines, if you had to get down to the motor, might take you 5-10 minutes just to get to the motor. We could take one step back and make it easier. Yeah, the problem may be at the motor, but in order for me to take this motor, I take the filter out, take the screws out, lift the top off, take the front off, take the belt loose, take the drum out, just to make that one test in the motor. Every other component in here, timer switch, thermal fuse, push to start relay, and door switch, are all right here. Everything's right here. The only thing that I can't get to from here is the motor. So let's not go right down to the motor unless we have to, and I'll explain that in a minute. So where is the closest to this motor that I could test back here? Like, in other words, if I said, look, I need you to go to the store, what's the next closest point to that store between here and there that you would be at? So in other words, what'd you say?
Timer switch.
Okay, so you're talking about this timer switch here? What point on the timer switch would be the next closest point?
RE.
RE, that is correct. RE is as close as you can get to the motor without going to the motor. So I can move my meter lead here to RE. What's the next, on the other side of the motor, where's the next closest point that we could get to?
The thermal fuse.
The thermal fuse, but where? Be specific.
4M.
FS1. Here, very good, James. Right there. That's as close to the motor as I can get from back here. Where is that? Well, in this case, it's not RE. It's blue on the timer. Okay, I know, like I said, I told you the colors aren't the same. So I'm going to take the red one and put it, the black one and put it on the timer. Here, which goes to the motor. And I'm going to take this one and put it to whichever one's FS1. Now on Whirlpool, a lot of times on the wires they'll mark the letters. I don't see it on this one, but I'm just going to go on one side of that fuse for now. Okay? If you don't know which one it is, one of these blue wires, this one right here, if I follow that wire, it goes to that one that I'm connected to. That's the one going to the motor. So that's as close to the motor as I can get at those points. So what do I do now? I connected my meter at these points. What's the next step? How do I do this test now?
Plug it in
Okay, we plug the machine in.
and press start to see if we get power to the motor.
Okay, we press start to see if we got power at the motor. We got to turn the timer into the cycle, right? Which
Right.
cycle are we going to use?
Honestly, any of them
Time
will work.
dry.
Time dry would be the best.
Okay, time dry is the most common cycle most people use. What if time dry didn't work?
Then
Would you try auto dry or air dry or any of the other cycles that the machine's given you?
Yeah.
Yeah, you would check every cycle.
Yeah.
Because maybe it works in one cycle and not. The customer only uses one cycle on the machine. They didn't try the others. Okay? So you go there, and let's say I have 120 volts there. What does it mean if I have 120 volts at these 2 points?
That the motor is good.
The motor has
No, sir.
power.
No, sir.
Power, yeah.
The motor,
What was the question?
what does it mean if I have 120 volts there?
Your problem's not what you're testing.
Well,
You wanna work
I
with
mean, you
that
guys are all close in your answers, but
Okay, so let me rephrase it. There's power getting there, but it's not completing the circuit. It's not completing the actual the path.
no. See, when a scientist does an experiment fails or passes, the experiment may not have answered the question why they were experimenting in the first place, but whatever the result was means something. And if part of it works, then they add a little more ingredients or do a little bit more trying to get to the answer. But the answer that they get means something. And I want you to think about this. What does the voltage at that point mean to me? It means I have voltage to that point. Therefore, if I have voltage to the point, what components in that circuit are good?
The ones before the motor,
So be specific and tell me what components.
the timer switch.
Okay, so I'm just gonna use a different color. So the timer switch is good, right? So I know that oh, I'm sorry, I wanted to be on this one.
Or at least that part of the timer switch is good.
I know that power's up to this point, but what else?
The motor itself.
No.
We said that.
What about the other side of the motor? Where I'm testing and telling you I got voltage at that point,
What, you mean the little piece of wire?
not the little piece of wire, but where
If
is
it's
that red
one?
meter lead? What?
FS1,
But what are you saying by we say FS1?
that you have power over there on that
I have
side.
power. I have power here and here.
It's reaching FS1, but it's not.
Well, what's reaching FS1?
Power.
Not power.
Current,
Not voltage. Right? In a way. Neutral. Neutral is all the way to this point. If this timer was broken, line 1 would not be on the black meter lead. If this fuse was bad, or the start switch or the door switch was bad, I wouldn't have the neutral on the other side of the meter. If either side was broken,
you wouldn't have no.
I wouldn't have a voltage reading.
Okay.
I don't know which side is broken if I don't have voltage, but if I do have voltage, it tells me everything up to that point is good. It's telling me my timer switch, my thermal fuse, my relay, and my door switch. So basically, every single thing that I wrote down there is good.
Working.
One test, voltage. Second test, here, boom. I've just eliminated every one of those components in the circuit with one voltage test.
Okay, I see what you're saying.
Is that faster than ohming out the door switch, ohming out the timer, ohming out the start switch, ohming out the fuse? Yeah, you can ohm them out. There's nothing wrong with that. Time-wise, I've just checked the circuit. Voltage testing is not checking what's in between the meter leads. It's checking the circuit up to those meter leads. It's telling me where the voltage is. So I know that every one of those components are good. If I did not have voltage, something's broken on either side, and we'll talk about that in a second. But one voltage test just eliminated 5 parts for me to test. The most likely problem that I have is where?
In the motor.
The motor.
itself.
But what I need to do is I need to take my meter leads. Now I have to go to the motor and check to make sure I have power at the motor. Why? Because there are wires that come from the timer to the motor
And the wires could be broken.
and from the fuse to the motor, and I could have a bad wire. There's many times that a wire has broken, not always. Like this one here, we got a wire nut on the wire because it was repaired. But there's many times a wire is broken, and the guy says, oh, I got power here, the only thing it could be is the motor. Ma'am, I'm gonna order you a motor. And they go and order the motor, a week later come back. Another technician has the job to put the part in. He goes in, tears the whole machine apart, break that blower wheel loose, and that's not easy sometimes to get loose. Remember how hard that was? Break that motor loose, pull that motor out, put the new motor in, go through all that, put the machine all back together. He presses start, the motor don't run. Now he's upset because he did all this work changing the motor, and he didn't fix the machine. I don't know how many times I've gone behind another technician to install a part, and after I changed the part, it didn't work. I finally realized, man, I don't care who the technician is. He could be a better technician than me and know more than me, but before I put that part in, I'm going to test that circuit again, because I don't trust anybody. Because you don't know how many times a guy who's got experience like me walks up and presses the start switch and, okay, I'm going to order a motor. Yeah, I've always seen, every dryer I've seen has been a bad motor. And I go and order a motor without making any tests. Another guy comes back and he sees me at the end of the day. Man, I changed that motor and it didn't fix the problem. Okay, so if you want to save yourself some time, spend an extra couple minutes confirming that the problem that the guy did. Could you imagine someone saying a compressor's bad and you went and did a sealed system job, changing the compressor, an hour and a half later, put the compressor in and it's still not running? One, you spent an hour and a half of your time and you got a long day after that. Two, the customer's standing over, you've been in their house 2 hours, it's still not running, and you got to tell the customer, ma'am, I got to order a control board because compressor's not working. Where you could have made a quick test and said, I'm not getting power to the compressor. So verify whatever a technician does. But troubleshooting is a process. It's a thought process. Okay? So identify and order parts that most likely fail. Most likely the thermal fuse is one of the first things to go bad. Okay? So if you didn't have voltage, we could go through the process of troubleshooting out those parts in an order we think that would fail most. Thermal fuse, door switch, and then start switch and timer switch. They're either or, but they're both right next to each other, so it'll only take you a few minutes to ohm them out if you need to ohm them out. But troubleshooting test circuits, not just the components, but it also the wires up to those components and the interconnecting wires. Let's look at it the other way though. Let's just say we were at this point here and here, and I didn't have voltage coming to that point, right? What's my next test? Do I check the door switch? Do I check the thermal fuse? Do I check the timer switch? Do I check the timer motor or timer contact?
You move your meter leads.
And where do I move my meter leads?
You expand your search. So you go from RE instead, just to be safe, you go to yellow, and then from RE you go to FS2. And the only reason I do it that way is just in case it's maybe the timer, maybe the fuse, and if not, one gets switched back so you can narrow down who's actually failing.
Well, an easy way to narrow down, remember testing circuits, is go back to those 3 screws in the back of the machine.
Oh yeah.
Because if I'm right here and my meter's telling me 0 volts at this point, okay? I need to know, okay, I don't have voltage there. Where is my voltage? How far did it go inside the machine? If I move 1 meter lead, this one, to line 1, and all of a sudden now, I got 120 volts.
Then we know on the other side where neutral is the issue.
So tell me, what information is that giving us?
It's giving us where it's located that the failure is. Or at least what side so we can diagnose to see where the failures are.
Okay, but
It's telling us what's working with
what is working?
line 1 to
Line
No.
one to the motor.
No,
to
The timer.
no. I'm at the power supply with my black meter lead. So I took the black meter lead
Oh.
and I'm at the power supply here.
No, okay, the fuse, the push to start, and the door switch are working.
Ah, because I have voltage here, in order for my meter to read voltage,
We move the neutral over.
the neutral is there. So my meter's here, but this meter's here, and I'm getting 120 at that point. In order for me to get 120, I need line 1 and neutral. I'm at line 1,
And that's all that is
Neutral.
neutral.
is here, tell me there's neutral up to that point. So I know that the fuse is good, the relay is good, the door switch is good, just by one meter lead movement. And again, I know the argument. Well, I could just go to Ohms and check out those parts really, really fast and figure it out. Yes, but in some machines, not every one of those parts, not in every machine are all the parts right here in the back that easy to get to. Okay? So you get as close as you can to the main part that's not working. And you see you got voltage there. If you don't have voltage, find out where is the voltage. What if my meter said 0 volts when I moved the black meter lead there?
You have to
What?
hold down the push to start.
Ah, okay. Well, we have to press the start button, right, in order to complete that circuit. Let's assume I did that. And my meter still said 0 volts.
Then you may have a break in the neutral.
My problem's on the neutral side. So then what do? I go like this. I take my meter lead, I put it back on RE. So I take this meter lead here, and I move it back on the wire coming from the motor. And I've moved this one back, and now I could do one of two things. One, I can move this one to neutral to confirm that I have voltage. So if I took this meter lead here and went to neutral and said, okay, yeah, I have voltage. I didn't have it at the thermal fuse. I didn't have it here, so I move it back over here, and yes, I had voltage.
So then your 3 components to check are the door switch, the push to start, and the thermal fuse.
So this is what we do. We go back to our first test point like I have it here. And now with the dryer, we hold down the start button and we just go back one step at a time. Here, 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 and here. So I go here, I just go to the other side of the thermal fuse. So I go like this, I don't have voltage, and I go here and my meter says, no, you still don't have voltage. So I moved it one step, I still don't have voltage. Now I went here, and I'm on the relay, the start switch, where it goes to the fuse. So this other wire is gonna go to my start switch. So I'm gonna take this meter lead, go to my start switch, and I still don't have voltage there. So I'm gonna go to the other side of my start switch, and all of a sudden my meter says, hey, I got voltage.
So now we know that the push to start's failed.
Yeah, it's power going up to the start switch, so power is all the way up to here, but when I moved this meter lead to the other side of the start switch, I didn't have it. So my start switch is bad. I know it's quiet, but are you guys following
Yeah.
what the backtracking is doing? Yes, we can check each component, but not only checking components, but we're also checking all the interconnecting wires. We're checking an entire circuit with voltage. We're not checking one part with voltage. When we do ohms, we're only checking one part. And we're jumping all over the machine checking one part, but one part, like this door switch, is in front of the machine. And if I have voltage at the start switch right now, the way it's wired in the diagram, I know my door switch is good because I have voltage to this point here. So I don't have to check the door switch. If you had the machine unplugged and you decide to check the door switch before you check the start switch, now you're taking more panels off to test a component that doesn't need to be tested, where a voltage test eliminated it for me. Could I ohm out the door switch from the back here? If I wanted to check the door switch, let's just say I go over here to push the start relay, I didn't have voltage. I say I don't have voltage here, but when I went to neutral, I did, so between here and here, most likely it's my door switch. Can I check the door switch for continuity from the back of the machine?
Yeah, you
Technically, yeah.
unplug R2 and then you go from R1 to neutral. But R2 had,
So I'm gonna move the red one to neutral just to keep them separated. And I'm gonna put this one on R1 on the relay. So I'm gonna take the black one, put it on the start switch, okay? I'm gonna take this one and put it on neutral. Let's go to ohms. And I got 1 ohm. Okay, so can you open up the door for me? So if I open up the door, I should say OL, and I got no reading here. Now when he closed the door, and I got a reading. Leave it. You want to see that?
yeah, I got it.
Okay, you understand? So I just ohmed out the door switch without going to it. Now in the competition, the judge wants to see you go down to it because the quick disconnect could be loose. One thing you have to be careful is the judge is supposed to watch when someone is working on the machine, and he's supposed to watch when the student's done that he put all the wires back. One year my student was checking out a dryer, a stove, and he's in the back doing all these tests, and he says, oh, I found the problem, and a plug on the control board wasn't connected. And the judge says, no, that wasn't the problem, reconnect it and start all over again. And then he didn't get it. So you know, like, how that would affect you. You're under a time limit. Yes, they added a little more time because you were checking something that shouldn't have been there, but you know, they want to make sure that.
How could he say that's not the problem if it's not?
Well, it's not the problem that was put in the machine for the student to troubleshoot in the contest, but the student prior to him had unplugged the board and didn't reconnect it.
Isn't their fault for not catching that before the next student? I mean, he found the problem.
Yes, but it wasn't the problem he's supposed to troubleshoot. Everybody is troubleshooting the same problem for fairness of the thing. What if you're competing and you're like, oh, well, I'll just pull this wire off so the guy don't see it and mess him up so he doesn't have to find the problem.
That's why the judge is supposed to watch.
Well, I'm just saying, those things happen, so you have to be aware. If you think something loose, you go up to the judge and say, hey, listen, I know the competition, you're not just gonna unplug something, leave it hanging. They're gonna put a problem in the machine that would most likely be in someone's home. Okay? So, any questions on this one? We'll go to the next problem. Yes, sir.
So you said something about a scientist when they do an experiment, even if it's not successful, it tells you something, right?
Mm-hmm.
So in the initial scenario, you were talking about saving time, and then later on you said that when you're testing for voltage, you're not testing the load, you're testing the circuit, correct?
That is correct.
So in a situation where you went directly to the motor, you were like, screw it, you take everything apart and you test the motor while it's running.
Okay.
That's not telling me definitely the motor's good or bad. It's what is that telling me if I do test the motor for voltage?
Okay, well, you said the motor's running. You meant to say in the cycle, because the complaint is the motor's not running.
Okay.
Okay, so I just want to make sure we're on the same page. So the motor's not running, and you decide, I'm not going to do the test here. I'm going to go to the motor and test it.
Mm-hmm.
So what was our reading? Did we have 120 or not?
I don't know. I'm just saying, like, I don't understand. It's almost like you're saying testing the motor is not as good. Like, I feel like that's as direct
Well,
as it can be.
it's the best test you could make to see if there's power to the motor, and if you have power, the motor's bad. If you don't have power, the circuit's bad. But how many things did I list here?
4.
Now, there's 4 things on the back of the machine. There's only one motor on the front of the machine that I have to test. And getting down to that motor takes a lot of time.
Mm-hmm.
How many calls did you run the other day? 14?
Yes, but you still ended up having to go back to the motor and check it. Even after you tested those first 4, we still went back to the motor.
But if I did not have voltage at that point, if I did have voltage, I go right to the motor to confirm it. Oh, that's only one more test, and yes, I have to go down to confirm it.
Take everything apart. And
That's correct. But if I did not have voltage at these 2 points, here and here, then I don't have to take the machine apart, take the drum out and all that. That's only one component. But I've eliminated 5 components. I've tested 5 components with 1 meter lead test.
No, I get that part. So,
So-
when you said the scientist, when that experiment goes wrong or whatever, it tells you something. So when you're testing voltage at that motor, what does it tell you?
Well, what if the answer is 0 volts? You're telling you, well, I'm not even get power to my motor, now I have to check these 5 things. Okay? The only way it's gonna benefit you is if you go down to the motor and by chance you have 120 there and you say, okay, I'm done. My motor's bad. I don't have power. I have power to the motor, it's not working, there's nothing left to do. But you're narrowing your search down to 1 test instead of, if someone's missing in a field, the lady's kid, they went to a park, Yosemite Park, and a kid disappeared. And you said, well, I'm gonna go that way looking for him, but what do they really do when someone's disappeared? They got 500 people, 100 people, and they fan out, and they test a big grid area. Well, testing a big grid area slows down the time it takes to find the answer. And by doing that test, I'm testing more things with 1 test. I'm shortening my time. Yes, if I had voltage at that point, I have to go to the motor just to confirm it. But at least I only have 1 more test to do. If I went down to that motor and took everything apart and I don't have voltage to the motor, now I still got to go back and check all those other 5 things. And that's taken me a lot more time. So when you're in a customer's house, diagnosis is important, because the sooner you diagnose it, the sooner you either got the part, I got the part in the truck, I'm going to go fix it, or I have to order the part and I'm out of there. And I go do another job. But if you're spending 30, 40 minutes troubleshooting a machine, you spend too much time. It's got to be 10, 15 minutes from the time you get to the customer's door and walk into the machine to you're in your truck driving away. The only time it should take you longer is if you identified a faulty component and you have it and you got it complete. Okay? Yes, you can go to the motor. There's nothing wrong. It's just going to take you longer, and if you don't have voltage there, you still have to test the other components, and it's going to take you longer now. And you have to put all that back together again. Because not only am I taking the top off and the front and drum off, but now I'm going to take the back off and maybe up here to test all these components back here. So I'm taking more things apart than I have to. So I said we're trying to reduce our discovery time. Yes, sir.
So it's not all about continuity and ohming all the time. You gotta see this voltage.
Yeah, but continuity and ohming is important.
Um,
Okay? Continuity and ohming verifies that that part's bad. If you have voltage to a part or door switch, you have voltage on one side and not the other, there's nothing left but the door switch. But in ohms, what if I'm testing that motor and I have to have the drum connected in order for the motor to run. It has to hit a belt switch or whatever. I can't be in there while the motor's running to make a test.
Right.
A washing machine, you got a motor and a belt and everything. You're trying to check voltage. You can't be there with moving components. What about a microwave when it's 4,000 volts of electricity? You can't have your hands inside there doing all these tests with high voltage because of the safety. Yes, sir.
Can you get a voltage tester?
Yes, but it won't check neutral. Now, if this door switch is bad, the voltage, the little thing that beeps and lights up, you go beep, 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 beep. Beep, 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 beep. It stops right there. So I know I have it on this side. It's going to have voltage pass through the motor and stop at that. Because neutral's here, but voltage is here. You say, yeah, but the motor's there. if the motor's not running, the voltage will go up to this point and stop. Just imagine voltage as this is a water hose here. If I turn on the water's going to run through the motor up to this point, and then the water's going to stop. Okay, so if I had a voltage test meter, yes. But if we get to a 240 volt circuit, no. Because you have voltage everywhere. I'll explain that in a minute. Okay, let's go on to the next diagram. The heating element doesn't work. Okay, first test is what? Power.
Yeah.
How much power now?
240.
240. We assume that the motor's running and the heater's not working by the complaint, but we want to verify it, right?
Mhm.
So I'm going to put 1 meter lead on line 2 and the other meter lead on line 1 here and here to see if I get 240 volts. Now in a competition, let's go back to the motor just for another second. In a competition, you can say the motor's bad, but if you can ohm out the overload or ohm out the windings and be specific, say it's a bad run winding or it's a bad overload, the judge is going to give you extra points because you knew exactly what it was. And you're like, yeah, but I said it was the motor. I knew it was the motor. I had 120 there. Yes, but some people, when they troubleshoot, put the meter incorrectly and get a reading when they're not supposed to. And they say it's the motor, or they're running out of time, and they say it's the motor as a guess. And the judge said, well, you got it right, but I didn't see you make these tests. I don't know 100% whether you're guessing that it's the motor, or you know exactly it's the motor and why it's the motor. Know what I'm saying? Because there are technicians that make tests, and they got 1 meter lead on the thermal fuse, and they got the other meter lead on this thermostat. Well, the thermal fuse controls the motor, thermostat controls the heater. If he's got 1 meter lead there and there, he's definitely not making an accurate test. That'd be like putting one meter lead here on the thermal fuse because the motor's not working, and he's got this other meter lead here on the thermostat. Well, what does that thermostat have to do with the motor circuit? It doesn't. So the guy's making tests, he's trying, but you got 2 minutes left. Okay, the motor's bad. Well, he got it right, but I know he didn't actually test it. He's guessing. And that's the same thing you go to a customer's house. Yeah, you're running out of time. You just say, look, I'm just going to order the board, and that's it. But guys go out there and change the board, and that doesn't fix the problem. Okay? So let's go to this one. So we go here, and we have 240 volts. That's correct. The motor's running, and we have proper voltage. Now let's identify the circuit. The circuit now is the heating element. What are the components or controls in that circuit that could stop the heater from working?
The timer.
Okay, timer switch.
Temp selector.
And that's Y to R.
Right.
Temperature selector switch.
The
What's
operating
next?
thermostat.
Op, T-stat,
High limit.
high limit,
The heater.
T-stat.
Well, no, the heater's a low.
Well, we'll put the heater,
And the centrifugal switch.
and I'm just gonna abbreviate it, cent switch, 1M to 2M.
When you say the heater and the heating element, are you talking about them?
Yes,
as
sir,
a-
I'm talking about the same component. Okay, so now we've identified the circuit. We looked at the line we drew, and everything in that line that sends power to the heater is something that we need to test. So what's the very next test that we need to do?
Put a meter lead on H1 and a meter lead on H2 and see if you have 240.
So we're going to then move our meter leads
So quick question.
to the heating element. 1 second. Here and here for check your voltage. Go ahead.
Why do it that way versus AHL2 and test everything in one go like you said?
AHL2, because that isn't finite enough. In other words, if any of these components here, centrifugal switch, heater, high limit, and operating thermostat are bad, if I'm on AH, even my selector switch could be at fault. I'm too far away. Like the motor, what was it that I said? Take the motor and try to go as close to the motor as you possibly can. In this case, we have these two thermostats and the heater, they're all here by the heater. The thermostat, high limit thermostat, thermal cutoff. This one doesn't have the thermal cutoff on there. Like I said, it's not exactly the same diagram.
So it would be fairly quick to just move one lead again and again and again to the tops, no? Or it'd still be
Yeah,
faster to test
but
this?
if I'm here and here and I don't get a reading, let's just say the test that you said, I'm gonna go to line 2, and I go here, and I have 0 volts.
You move it, the black lead over to AH1 and you keep following it until
No.
it's
No.
done? Oh, I'm sorry. Yeah.
The only thing, if I don't have voltage, is the bad timer.
Oh, true, okay.
Because I'm on line over there.
Mhm.
But if I do have voltage,
I said it.
I still have a centrifugal switch, the heating element, that thermostat, and the selector switch. In other words, I'm not really like, narrowing it down, so to speak. I'm in the middle of the circuit trying to say, well, do I go left or right? So what I do is I go to the heater, here, and here to see if I have voltage. So now I take these two from the power supply and I go to both sides of the heater and say, do I have 240 there? Because if I have 240 there, what's my problem?
The heater's bad.
The heater's bad. Do I need to ohm it out?
Not really.
No. Because there's nothing left. If I have 240 there, that means my centrifugal switch is closing. And it means all these thermostats and timer switch and everything else are closing, because I wouldn't have 240 if any one of those parts failed.
So in the competition, we would put heater failed short.
No, it would be open.
You
A
said,
short would be like
Oh,
a
yeah,
short
okay,
circuit,
yeah.
and it would blow a fuse.
you said H1 to H2.
I have 240 volts. So that means my heater is broken. It's open, not shorted. So when you use the term short,
I see what you mean.
that means it had a resistance value, and now it has no resistance. It's 0 ohms, like a door switch, for example, and that would be a short or a shunt.
Okay, well, I've had those heaters sag, hit to neutral, or hit to the casing, and then I end up with a heater that's supposed to produce 2,000 watts worth of power, or heat, producing like 750, because it cut short. That's technically a short circuit.
It's a ground. It's not a short circuit. It's a grounded heater. Well, we've had on these heaters here.
The disassembly is crazy. Cool.
On this heater here was very common if a customer had poor airflow. Back in the day, when they made this machine, the heating element used to go up inside here and go all the way up to here. And you had to take this bracket off, which now the screw's coming this way, but it used to go this way. And I think the other one, the Kenmore machine I have, had the diagram glued here, and you see a little hole. And if you look through that hole, if you had a long enough nut driver, you had like an extended nut driver, you could get to that screw from here, and you just reach up here and take it off. So you had to pull this out. And there was a screw through this hole holding the heater on the other side and pull it out. So Whirlpool decided, let's make a change and let's make this shorty heater where they just pull this off and replace this, and now we got a heater. But the problem is the heater was on this side and the other side of that metal divider. And right here at the top, the heater crossed over. And if the customer had poor airflow, that wire would sag and touch the metal here. And you say, wow, if it touched the metal, it's going to blow up. But it would touch the metal right in the center of the heater. And so half of the heater would get voltage all the time. Thermostat over here tried to shut it off, but half the heater's still running to ground, 120, and still heating. It overheats. Okay, but let's go back to a problem. So let's say we don't have 240 there. Let's say our problem is we're not getting the proper voltage to the heater. Okay, we had our meter leads here and here. We need to figure out which side of the circuit is our problem. Now, one thing people do which is inaccurate is they'll take this one and go to ground, or they'll go to neutral and they'll get 120 volts. And they'll say, oh, well, I got 1 meter lead on H2 and I put this meter lead on neutral and I got 120. That means my centrifugal switch is good because that's one side of the circuit.
No.
You cannot check a 240 volt circuit to ground and find the problem. Let me explain to you why. And I was prepared to talk about this, so I'm going to switch to a blank screen real quick.
Quick question, while you're doing that?
Yes.
Would you technically be able to do, totally separated since I know we're supposed to do voltage tests, but humor me. Would we be able to do line 2 to H2 continuity to confirm that centrifugal switch is working? Yeah, right.
Yeah, we're gonna talk about that in a second. I just want to talk about this. Okay, so let's just take a look. That I'm gonna do a switch. I'm gonna leave that switch open right now. This is line 1. And then I got the heating element. And then I'm gonna go over here, line 2. Let's just say the problem with this heater not working is because that switch is bad. All right? Now you're like, well, I got neutral here. And line 1 to neutral and line 2 to neutral is going to give me 120 volts. So if I want to know if this side of the circuit is the problem or that side of the circuit, I'll leave 1 meter lead here, and I'll put the other meter lead here, and I get 120. So that means what? This side of the circuit's good, right? Right? I got 120?
Yeah.
I'm on line 2. I'm on neutral. I'm supposed to get 120, right? But what if I take this wire off and I put it here? What am I going to get? And the other one I left on neutral.
Nothing.
I'm going to get 120.
Through the heater?
Yes, the heater's going to become a path. The heater's very low ohms, 8 ohms. And if there's no amperage running through it, there's no voltage drop.
Oh, okay.
Have you ever had a hose laying in the yard that might have had a kink on it, but you pushed the gun and water shot out?
Yeah.
And once the pressure in the hose shot out, the hose went because the kink over here didn't continue to feed it. But when it was off, the kink had enough where it allowed that side of the hose to fill up so it had pressure on it. So if I went on the other side of the heater, I'm going to have full voltage. If I move this meter lead to here and neutral, I have 120. It's going to feed back through the heater. If I move the meter lead here, now I'm on line 1 in neutral, what do I get? 120. So you cannot check a 240 volt circuit because how much power does it take to make that heater work?
240.
240. You have line 1 and line 2 up to everything. But now line 2 is further through the circuit than it's supposed to be, and it's still going to give you a voltage rating of only 120. It is not an accurate way to do any test. If you had a digital voltage tester, the ones that beep and light up, I'm going to have a voltage everywhere in this entire circuit when that machine's running, even though this is here. What I don't have is amperage flow, current flow through, and the heater won't get hot. So you cannot check a 240 volt circuit to ground to try to find the problem. Same on a stove. The same thing would happen. Okay? Let's go back to this circuit here. I don't have 240. Okay, so now I got my meter leads both on the heater. I turn the dryer on, my meter says 0 volts. So that means I'm not getting power. So it could be timer switch, selector switch, operating, high limit, or centrifugal switch. Now they're all back there, I can ohm them all out, sure. But what if I told you with one test, you would know which way to go? You would know if it's one of these or the motor problem. Could you imagine testing all these for ohms? And then you're like, oh man, I gotta go to the motor. But I took all this time to test these. Now these are easy to get to, but if you're talking about a Frigidaire or GE dryer, some of those thermostats you have to pull the drum out just to get to them because they're behind the drum down low. And you can't get to them without pulling the drum out. So yes, on the Whirlpool it's easy, but these are things you have to look at. So then, if I move 1 meter lead here to line 2 and leave that meter there and it tells me, now I got 240. I did not have it here, but I do have it here. What's between that test? Centrifugal switch. So it doesn't matter which one I take off the heater right now. I didn't have voltage. All I'm going to do is move my meter lead here, line 2. Do I have voltage now? Yeah, I do. Okay, my problem is centrifugal switch. I don't need to check any of those. Why? Because in order for me to get 240 volts, my meter leads up to this point here. My meter lead, my voltage is up to here, and my voltage is there. I know that all of these are good because I have voltage where that meter is. I just tested 1, 2, 3, 4 components by moving 1 meter lead. Now, if I did not get voltage, I move this one back to here, and I take my black one. Yes, I could go back here. I could just take this one here and move it over here if I want and say, oh, now I got 240. Okay, well, I know my problem's on this side because it wasn't on that side. Okay, so now I got 240. That tells me centrifugal switch is good. But what I would have done then at that point, after that one test, is I just would have gone back and started backtracking here and here. High limit thermostat, both sides, here, here. So I move it here, from here to here. What's in between this test and this test? What's in between that? Just a wire. So I'm going to go from this heater here to the high limit thermostat. Okay, if I had voltage there, the wire is broken between the two parts. If I don't, I go to the other side of the thermostat. If I don't have voltage, now I go to this thermostat, the operating thermostat. And I go here. I don't have voltage, well, there's a wire from one to the other. I go to the other side of the thermostat. Here. Oh, I have voltage. I didn't have it here. I have it here. What's my problem? The operating thermostat. So I didn't have it here. I have it here. Well, voltage went from this point and this point, but this point right here, there's no voltage. So in troubleshooting, again, we're checking the circuit, but we're just following back the circuit. How far did electricity go? We're eliminating things, only moving 1 meter lead at a time. Now, one thing very important I didn't say at the beginning. When you are doing voltage test, if you can unplug the machine and set your meter and get your hands out, it's the safest way. If you do gloves and you're secure in your tests, yes, you can do what I did while it's live, but it's very dangerous, so you have to be very careful. I recommend gloves, unplug the machine, move your meter, plug it back in to start it. Yeah, it takes a little bit longer, but it's the safest thing. But when we do these tests here, okay, those tests are eliminating components every way we go back. Okay? Yes, sir.
Say for instance, if it's not a Whirlpool dryer, can you check for amperage on the board?
If you're checking amperage on the board, let me ask you a question. If the heater is not working, that's the complaint, are you going to have amperage in that circuit? No. So if I put an ammeter anywhere on this circuit, if that heater don't work, the heater is what draws the amperage. So drawing the amperage just tell me if the circuit's working or not. feeling heat coming out the back of the dryer is all I need. I know there's amperage if I got heat. If I don't got heat, there's no amperage.
Mm.
Follow what I'm saying?
Yeah. Thank you.
Okay, I'm not gonna do the other two tonight. We had two more on the timer, which is gonna take a lot longer. And we already went about an hour, and I don't wanna lecture too long because I'm losing some people here. So I don't want to like stretch it out. I wanted to do a refrigeration lecture. I might do the ice machine tomorrow, which is what I planned on doing. Okay, I'm gonna talk about a couple of different ice machines. But I wanted to go over this circuit. The other circuit was about the timer motor and automatic and time drive. But it's gonna take me a while to explain those circuits to you so you understand why it works this way or why it works that way and the troubleshooting. And I don't wanna go 2 or 3 hours while lecturing. Any questions on the the drive motor or the heater circuit and how you should check it out? Yes, sir.
Kind of following up with Kenton's question, what if there was another load in that circuit other than the heater? You're saying something about, cause the heater,
Well, this is a load, and if this switch is closed here, this is a load. But this load is more of a resistor with very high resistance, and the amperage is very low, where the heater circuit has a lot higher amperage. So you would get a different amperage reading. Okay, and you're like, well, how do I know what amperage I'm supposed to get? Well, while you were testing machines out in the class, I had you ohm out these components, right? Yeah. And on most of these heaters, let's just say the heater is about 10 ohms, right? So I need to know, okay, if I got a 10 ohm heater, what should my amperage be on that circuit, right? So if we go to a blank page here, I got 10 ohms and I got 240 volt circuit. Okay? Power is amperage times the voltage, right? And I don't have amperage and I don't have the wattage, which is power. All I have is voltage 240. Okay? But if I got 10 ohms and 240, what's the math problem to figure out? Pi. So we got two formulas. There's more than this. E equals I times R, and pi, P equals I times E. This is voltage, amperage, ohms. This is watts, amperage, voltage. Okay? What two readings do I have? Ohms and volts. Well, then let me use this formula and I'll tell you why. So I got 240 volts. 240 equals, I don't know the amperage, but I have the ohms. Well, if I want to get rid of 10, I divide by 10 here, I divide by 10 here. 10 into 240 is what?
2.4 or 24.
24 equals the amperage. So I know my amperage in that circuit should be about 24 amps. That's it, I'm done, right? Because you wanted to know the amperage. You say, well, what if there's another load drawing amperage? I think it's the heater. How do I know it's the heater or not that's drawing amperage? Well, I'm telling you, that thermostat heater is not going to draw anywhere near than 1 or 2 amps. This one here is going to draw 20 to 25 amps. Okay? Yes, sir.
That's just if you're not trying to test all the heater. You just testing by the board. That's why.
Well, you can check by the board or anywhere in the machine.
Yeah.
Anywhere in that 240 volt circuit.
Oh,
Okay? Yes, sir.
Most of the circuits I see in homes are 30 amps.
That's correct.
So they're just a little bit away from tripping it?
That heater is probably not drawing a full 24 amps. Okay? It probably drawing about 21, 20 amps with the motor running. It's about a good 70% of the max amperage when that dryer is fully running, when everything on there that's running. Okay, it's just like a stove. Stove's on a 50 amp circuit, but if you turn every burner on the top of the stove and every element in the oven and you got the clock running and the light on, you're probably pulling about 40, 41 amps. but you're on a 50 amp breaker. And even though
Hold on.
they say, 30 amps,
Yeah.
the breaker's gonna blow at 30 amps, but the wiring and everything
Could be
is
certain.
rated higher than 30.
Yeah. You're,
But go ahead.